We've all had that one teacher, right? The one who just got it. They can make the most complicated stuff suddenly make sense. And learning actually felt, well, easy. What if I told you that wasn't just magic? There's a real science behind it. And that's what we're diving into today. Educational psychology, the science of how we all learn.
So, let's start with a really big question. Is teaching an art? Something based on pure gut feeling and tradition, or is it a science? For a long, long time, it felt like a lot of it was just a best guess. Well, educational psychology is the field that's working to change all of that. Think of educational psychology as a bridge. On one side, you have the science of the mind, all that psychology stuff. And on the other, you have the actual art of teaching, or what experts call pedagogy. Educational psychology connects the two. It's all about moving away from just guessing what works and into a world of evidence-based practice. All right, so here's a quick look at where we're going. First, we'll tackle that art versus science question. Then we're going to peek inside the learner's brain, figure out how to build lessons that actually stick, and then we'll crack the code on motivation. Finally, we'll see how it all comes together to create a way better education system.
Okay, let's jump right in with that first big question. Is teaching an art or a science? We've already said that just relying on a best guess isn't really good enough. So let's explore the scientific solution that educational psychology brings to the table.
I mean, it makes sense, right? To teach effectively, you first have to understand the learner. So we're going to go inside the brain to really get the why behind student behavior. And maybe most importantly, we'll look at how our ability to learn changes a lot as we grow up.
So a huge name you need to know here is Jean Piaget. He was a pioneer who figured out that our brains develop in these really predictable stages. And this isn't just some boring academic theory. It's literally a roadmap for teachers. It tells them what kind of thinking a kid is capable of at different ages, moving from really concrete stuff to way more abstract ideas.
And this is the perfect example of why that matters. A 5-year-old's brain is just wired for tangible, concrete things they can see and touch. These abstract ideas, like what x means in an algebra equation, it's just not on their cognitive map yet. It has nothing to do with how smart they are. It's all about developmental readiness. Okay, this leads us to another really powerful idea, this time from a guy named Lev Vygotsky. It's called the Zone of Proximal Development, or ZPD for short. Just think of it as the absolute sweet spot for learning. It's that magical space between what a student can already do by themselves and what they can almost do, but just need a little guidance. That's where the real magic, the real learning, happens.
All right, so knowing when a student is ready to learn is one thing. That's a huge part of the puzzle. But the other half of the battle is knowing how to make that new information actually stick. So now let's get into the mechanics of memory itself, how our brains actually file away information.
Okay, so the key thing to get here is the difference between working memory and long-term memory. Your working memory is kind of like the RAM on your computer. It's super fast, but it can't hold a lot of information at once. It's like a temporary scratch pad. The whole goal of good teaching is to take information from that temporary space and save it to the brain's hard drive, your long-term memory. So, how do we do that? How do we make that transfer happen? Well, educational psychology gives us some incredible, proven tools. First up is scaffolding. Imagine a teacher giving you sentence starters for a really tough essay, or a step-by-step checklist for a lab experiment. That support is there to help you at first, but then it gets slowly taken away as you get the hang of it. Then there's spaced repetition. This is basically the ultimate enemy of cramming for a test. It's all about reviewing stuff at bigger and bigger time intervals to really lock it into your brain for good. Okay, but you can have the most perfectly designed lesson in the world, right? And if a student just isn't motivated, it's all for nothing. So next up, we have to tackle the big one, the motivation equation. Why is it that some students push through challenges while others just give up? Well, the answers lie in some really powerful psychological concepts. You've probably heard of growth mindset from Carol Dweck. Her research showed that students who believe their intelligence isn't fixed, that it can grow and develop, are way more resilient. This is exactly why a great teacher praises a student's effort or their clever strategy, instead of just saying, "Wow, you're so smart." It builds that belief that you can overcome anything with hard work. And this all really comes down to the difference between two types of motivation: intrinsic and extrinsic. Intrinsic motivation is when you do something just because you love it, you're curious about it. Extrinsic is when you're driven by outside rewards, like getting good grades or praise. Now, don't get me wrong, grades have their place, but the science is crystal clear. When you can spark that internal curiosity, that intrinsic motivation, that's what leads to really deep, long-lasting learning. Okay, so far we've been really focused on the individual student. But for this last part, let's zoom out and look at the big picture. Because the impact of educational psychology goes way beyond just better lesson plans. It's really about building a better and, frankly, a fairer education system for absolutely everyone. And the practical applications here are just huge. We're talking about shifting from old school punishment to things like positive reinforcement for managing classroom behavior. It gives us the scientific tools to identify learning differences like ADHD or dyslexia way earlier. And it's the entire foundation for what's called differentiation, which is just a fancy way of saying we can tailor lessons to meet the unique needs of every single student in the classroom. And this slide, wow, it really brings everything home, doesn't it? For teachers, it means having real scientific tools and hopefully feeling less burned out. For students, it means they get learning that's actually engaging and designed for their stage of development. And for the system as a whole, we're talking fairer tests, better curriculum standards, and actual evidence-based mental health support. It is a win-win-win. So, the science is here. It's not a mystery anymore. We actually know how to create much better learning experiences. The real pressing question is, are we using this knowledge? Everywhere we should be, in every single classroom for every single student. Now that's the challenge, and it's something I think we all need to be thinking about.